Cynthia. Okay, so today we'll have the pleasure of hosting Cynthia Rivera Jimenez from the University of Florida, Department of Engineering Education, and Kimberly Stumps from the same department. And they will tell us about engineering education, broadly speaking, but also at a more personal level, and see how the connection with two-year colleges does affect that. Okay. Well, thank you. So I'm going to let you, Cynthia, go ahead and share. And let me stop
Yeah,
sharing that. And
sure.
should be able to, is she able to share, Chris, at this point?
Yes, I can.
Okay, you can. All right. So go ahead and take it from there. Thank you.
So thank you everybody that was able to join in a Friday. So thank you. So I am a professor, assistant professor at the University of Florida in the new engineering education department. So as a discipline, engineering education started fairly recently in early 2000s. But my trajectory started actually at Santa Fe Community College. I am a graduated chemical engineer from the University of Puerto Rico, and I spent my first 4 years in this country working as a chemistry professor at Santa Fe. And I was really lucky to see the birth of the Gator Engineering Program, which is a very unique nationally program where students that don't get accepted at the University of Florida, they are accepted to this community college. I'm so sorry, I'm in a conference. So they get accepted to the community college and they have the option and a pathway, right, where they don't need to finish a 2-year degree. They can just transition more smoothly to the 4-year institution. So with that context, I evolved my career and I did everything. Assistant engineer, I did a lecture, and until 2 years ago, I got an assistant professor position where I'm conducting research in engineering education. So one of the things that I do in my research is to look at the student within a ecosystem. So I'm going to show you a quick slide because I am an engineer and I like drawings at the end of the day. Let me show you. I'm so sorry for the noise. Everybody's leaving. So, so this is an ecological system theory approach to look at the student experience. So I wish I could do the experience of the student at 2-year institution, but I recognize and honor that, doing research at a community college level takes more time. I was a professor, so I know. And sometimes they have a little bit of challenges as a faculty to do so. So I decided to start my work at 4-year institutions. So if you look at here, I look at the classroom as one particular level in the system where the student experience happened. So if you look at the center right, you have this individual student experience that is shaped by what we do in the classroom, but that is not isolated, right? The student, one individual student experience is influenced by their peers, is influenced by their department, by their institutional culture. And in the bigger ecosystem, right, it is shaped by organizations like the one, right, that you are for, like the physics organization. In my case will be chemical engineering or engineering education, and also any type of board that shapes the standards on how education should happen. And then the learner, right, is kind of like coming through that pathway. I don't like the pipeline. I don't like the pipeline metaphor. I actually like, I'm here in a conference and we were talking about a river, right, that, a student can just flow from different places to meet what we call achievement outcomes. The other thing that I like to think about achievement outcomes is, stepping outside the learning outcomes in the class, but also thinking about what are the meaningful outcomes for the learner. Like, is it really attrition if the student comes to engineering but later decide to go to physics? Are we really losing them, or are we just helping the student to have a success outcome, right, that is more aligned with their happiness and what they want to do in their life? And there's also institutional goals, and then professional organizations' mission and society benefit. I'm right now in a conference on the role of professional societies on influencing college experiences. So in this scope, right, my research kind of centers on understanding transfer transfer students beyond what we call the transfer shock. So the literature says that when the student transfer to the four-year institution, they have this drop on their grades, and many of them end up leaving or leaving the discipline or just dropping out from the university. So we recently got access to 20 years of academic data at the University of Florida, and we find out that even though the enrollment of students through the program like Santa Fe increased with time, the persistence of the student in the discipline didn't. It's not directly related. So my research questions are, what are the system doing to support the students when they arrive, right? And what are we doing as a college to make sure that the students are making the right decision before they come? And the reason is because when they come to the big universities, so many universities have policies that the students cannot change degrees. So what end up happening is that if I decided to be a material science engineer, and then I decided that chemical engineering is the way I should go to, I cannot transfer, or that will delay my time to completion a little bit longer, just because there's so much bureaucracy and things like you have to overcome. So that's kind of the scope of the work that I do. I'm interested on research questions, again, about the individual. I do qualitative work. I manage large data. I try to incorporate stakeholders, like my research and my proposals include the dean, the academic advisors, professors, and things like that. I also care about providing experiential learning in the sophomore year, which tends to be when the transfer students kind of like come to the university. And we are developing lab kits that I'm trying to collaborate with Kimberly too. She's in that area too. And the idea is that when the students come to like transport phenomena courses, they can quickly connect physics and chemistry concept to the application of the concepts into the engineering context. So again, there's a lot of physics connected. So if you're interested in using this, we made them at the university. They're super cheap, like $100 per kid, where you can kind of like do experiments with transport phenomena. You can explore different phenomena, and you can connect that to mathematical equations and things like that. So again, that's where I am right now. If you have any questions, I'm happy to help in answer.
Okay, so thank you. So I guess maybe we'll have you, Kimberly, tell us a bit more about your own path through that, and then I'll have a few questions. Maybe I'll come back to that in a minute, because there are a lot of things, interesting things in what you just said, Cynthia.
All right, so I don't have any prepared comments, but rather I can share with you my experience coming through the university system and ultimately becoming a relatively new faculty member in the engineering education department. So approximately 8 years or so ago, in my early 40s, I decided to explore and pursue a degree in engineering, and that started at St. John's River State College up in Clay County. Coming from the perspective of a student who has not taken a science course or a mathematics course in more than 20 years, the small classroom environment and the focus on experiential learning made a lasting impact for me, in the sense that I had the opportunity to really work individually with the professors, and seeing, after having lived 20 years plus as an adult, getting to experience the physics concepts from more of an experiential small classroom environment, and that type of perspective really made them real for me. And so that focus on the small classroom interaction with the students and the focus on problem solving, I felt really prepared me for the transfer into an engineering program. My degree is in mechanical engineering, so the majority of my continuing classes at the university level were physics based. And so having that strong foundation that I feel, based on my conversations with people who maybe have come through not in a 2-year system, taking those courses in a large auditorium environment, that maybe they didn't have that same level of understanding, that same focus on problem solving. So because of that, because I felt like it was so impactful for me, now as I approach my courses as a faculty member, I try to find ways to incorporate experiential learning every opportunity that I can, because it was so impactful for me at the 2-year level. My current focus is I'm teaching computer programming for engineers, and I am just now beginning to explore some engineering education research topics, but those are really focused on incorporating experiential learning tools into a programming course. So really that's the experience I have to offer, only in that, I could give you what it was like for me as an older student coming through, having to relearn skills that were long lost. But any way that I can help this group is, I'm happy to get involved, because it was just so impactful for me. Physics was probably the most impactful course for me coming up through that 2-year program. So.
Well, one of the recurring themes in terms of physics teaching in two-year colleges is that we usually have a wide range of student population. And what you just mentioned is very important, because we typically think about the prototypical student who just finished high school is going to go on to college and so on. But at the community college, we do get that variety, and being able to teach to that broad population is always a bit of a challenge. And it's helpful to know what aspect of the teaching is valuable for someone who's not just fresh out of high school and has more experience with life. And so trying to incorporate that in the teaching of physics is difficult, but I think that's something I'm sure my colleagues here would agree is an important aspect of the way we teach physics in two-year colleges. So I wanted to go back to Cynthia, what you mentioned. So the transfer. So there's the great shock. I forgot the exact phrasing, but from the data that you've gathered, what would you say it would be if you had to rank challenges that transfer students are experiencing? What would you put near the top of those issues that students are experiencing? Just a change in environment, or change in the way the courses are structured, or the expectations are different? What would you say?
So the importance of conducting research that is contextualized to the institution that they transfers to is that most of the research that is out there, it is based on other states, like California, whatever. And every 4-year institution has different acceptance requirements for those students. So for example, places like New Mexico or California, they tend to have what is called like low selection, like most of the students that apply get in. Universities like UF, they're highly selective. So you really need to understand that context, because the challenges will be different, right? So in the context of highly selective institutions, where the students are academically more ready compared to other students, right? Because they're passing this filter before entering. The preliminary data that is showing right now is the shock in the culture. So they are having a lot of issues with navigational capital, right? Many of them don't understand, going from a very small and nurtured environment that is the community college, for example, I remember teaching 50 students per section, and we divide the lab in two, and me, the professor, me, the laboratory manager, right? So that connection and that caring culture and servingness culture is really different in the 4-year institution. And it's not that the big institution, like the four-year institution is not caring, is that it's just bigger. So some of them have these issues with navigational capital, but many of them are able to cope with it, which is what I care about my study. Like some people say, oh, they have shock and they cannot do it. And no, they cope and they're able to find out ways because they're non-traditional to persist. So again, navigational capital will be one of the biggest, depending again on the institution, financial constraints, right? And work, that means that they have to work, they have like working and classes and things like that. And there's another one, I don't remember right now. And then their transfer alignment. Like when they come here, they realize that they lost some credits, or they had 2 credits that would not allow them to take the following class in the semester. So those are the top right now based on the literature. But once again, I just started this project. I'm just submitting another proposal for NSF to kind of like get to understand in the context of four-year institution, particularly highly selective institutions.
Okay. So Kimberly, in your case, from what Cynthia was just talking about, were the issues different in that sense because you were at an older stage in terms of student, or is the challenge pretty much the same, whether you're 20-year-old or 4-year-old?
I can tell you that the challenge was mostly the same. It was very much culture shock the first time. I will say my very first day on campus, I walked around and looked at everybody around me and recognized I do not look like anybody at this campus right now. So that was a little different, but that was okay. I was prepared for that one. But generally speaking, everything that Cynthia mentioned, I absolutely can agree with. I stepped into larger classrooms than I had ever experienced before. My relationship with my peer mentors wound up kind of replacing the relationship that I had previously had with the professors due to the smaller course load. So that took some time to transition, but as Cynthia was also mentioning, I think UF's a little more selective, so perhaps those who are transferring into UF are more prepared to make that or deal with those challenges. I haven't seen the data as India has, but I can certainly agree with all of the challenges that she had mentioned.
So we have collected some preliminary qualitative data too, because we identify factors and we try to collect some data, and many of them, UF have a strong student organization presence. So once they click on a student organization, you can see that, you know, they'll cope better because they have peers. They have peers in the, which is something that the Santa Fe students can do it faster than the rest, right? Because they already have a transition process. It's, you know, because of the nature of the Gator Santa Fe program, which is really unique, once again. And those clicks happen faster, and they are able to cope because of that. You can see many of them get into, I don't know, like the design teams, or they start getting to the chemical engineering organization. They start getting involved in leadership roles. Mm-hmm. One of the other things that they say that the challenge compared to in the engineering, those of them that goes to engineering, is that engineering is highly experiential. So they feel that they don't have the opportunity to have done research before or work to the industry and things like that. So I'm working with the advanced manufacturing industry in Jacksonville, and this group of Flex Station and things like that. I'm sorry, FLATE. It's called FLATE. And they're trying to create a consortium where students at the two-year institution can start doing some internship in the local industries. So when they transfer, if they decide to transfer, right, to a four-year institution, then they have that experience, and they don't need to extend a little bit more their time, because it's not really 2 + 2. It ends up being 2 + 3, because in engineering, you need to do a co-op, particularly if you're a chemie. They would not hire you if you don't do a co-op. and that is 6 months, a minimum 3 months of an internship. So again, those opportunities to link with the local industry, I think, is important. And I know that the Florida Semiconductor Institute at UF, there's a lot of initiatives that we're working to see if we can just provide those opportunities to students and maybe decide that they don't want to do the 4-year program. They want to do, engineering technician, or they just want to go directly to the industry, which is completely okay too.
Okay.
I will add, one of the difficulties that I had with transitioning into UF, and this is specific to the fact that I came from an institution that did not tailor their program towards UF's curriculum, but rather the SJR State is tailored more towards the curriculum for University of North Florida, being a closer university for that program. And the challenge that I experienced was relative to notation was different from the courses that I had taken, and then stepping into UF. And, UF, you hit the ground running, and, the professors are presenting, complex equations from day one, and coming from a program that had completely different notation for vectors and matrices, it took me a while to make that transition. And then similarly, a little bit to what Cyndia was mentioning regarding sometimes you find out that your courses don't transfer. The other challenge can be when the material covered doesn't necessarily match what is expected at the university you're transferring to. So for example, linear algebra was not covered in my program in any aspect. So I guess the best way to say that is, when the program, the university program assumes a level of knowledge that doesn't exist, that can be a difficult transition as well. And I don't know how you approach that. I don't know how you kind of approach that mismatch.
So there was a quick question that Chris put in the chat here. So if there's a TYC or TU College cohort transferring to the same 4-year program, do you think that helps protect against some of the shock? If they were to transfer as a cohort, would that help a little bit?
The answer is yes. And even in the broader literature of bridge programs and transfer and transition programs, whatever, it could be high school to first year or whatever, yes, the answer is yes. So what you see is that bigger feeders of students, it becomes like a stream, because, for example, many students come from Santa Fe, right? They build cohort there. Santa Fe, the students that transfer from Santa Fe, then they meet the seniors, and then they kind of like give back, right, and mentor them. Some of them even move together, so they have like that connection. Many students that come from Valencia, from Miami-Dade, is the same thing. Yeah, they know who comes, and we're humans, right? This is human behavior. So if we build cohort, it does help. Students, the most challenging group of students are actually international students, because international students have very unique needs, and the only service right now in STEM that we're providing is not even in STEM, it's through the International Resource Center. So they need specific things. For example, they cannot do an internship like anybody else. They need to apply for a visa. They need to learn how to navigate certain aspects of the curriculum that other type of students don't need to think about it. So those services are not in place, for example, and therefore offices like the first year advising office is not equipped to help this population of students, because they're not the same issue. So it is cohort building, but it's a specific need that they have.
Okay.
I'm working with foundation money through chemical engineering to see if we can create the first bridge program. And that will include creating a program at Santa Fe, because Chemi doesn't have any of that. Actually, my son just became a student at Santa Fe. So I not only I do this research, but I have a specific heart, right, and intention to make him be successful. So if he'd applied to Chemi, which is what my husband and I are, he
Mhm.
would not be able to do what he's doing right now. So he applied to material science and engineering. So Kemi, who is Carlos, who works there, realized that we need to create those bridges so students can come through that pipeline. And through foundation money, what we're trying to do is kind of like a bridge program where they come together. We can do a student organization that
Mhm.
kind of like lessen the navigational problems that they have, at least during the first year. The second year, they're like integrated. So
Yeah.
they adjust very well, those of them that cope, but that first year is so critical. And that's good thing, Chris.
So in the in your experience from overall engineering, I mean, is Florida a particular case, or do those lessons apply to every state in terms of coordination? It seems like in Florida we have a more articulation going on. Are different states reacting differently to that issue?
So UF is not as well organized like UCF, FIU. So I am including those universities as part of my advisory board. And the idea is that we can create a regional hub and share best practices. You have, I think UCF is a Hispanic service institution, and they do have like Sarasota area, and they have big, strong collaboration, right, with this how you call it, the community college that is in Sarasota, the Manatee, I
Oh,
don't remember right now,
Manatee Community
in the
College.
Manatee area. So they have really good transition programs. They have organizations like a student organization that help them, like ambassadors kind of deal, that is just focused on this. Yeah. So, but at UF, we don't. I think I am one of the first asking those questions, and I'm very happy to be working with that.
Okay. I'm just curious, like John or Tom, do you have similar things in your areas and in terms of coordinating with the engineering programs, or no? Because I'm wondering how how this model can be, shared with across different areas of the country. Yeah. Oh,
Thomas,
Tom,
you're muted.
I think you muted Tom.
My area, our students transferred to either the University of Houston
Mhm.
or to Lamar University, and then some went to UT and Texas A&M. So we had a fairly close articulation arrangement between us and U of H and Lamar, as well as UT and A&M. But that way, it minimized the transfer problems. They still exist, but it minimized it as much as we probably could do.
Okay.
But
Good.
one of the things that was pointed out is some of the courses aren't offered as often at, say, at my community college as it would be necessary for transfer. So, for instance, linear algebra was one of those. We offer once a year. And so if that doesn't fit into the student's schedule while they're still at the community college, they would have to take that when they transfer to university. We try to arrange that so that they would have that available, but their schedules don't always match then when it's offered.
Okay.
And the same is true for differential equations. It's only offered once a year.
Yeah.
So earlier, Cindy, you mentioned something about the role of the professional organizations. Like I know, for instance, the Hispanic Engineering. I forgot how it's SHEP. SHEP, is that the right?
SHEP, yeah.
Would it be useful to have either representation within the two colleges or some kind of antenna there in different disciplines?
So the answer is yes. That does needs champions to do this. I know that Santa Fe, for example, which the proximity of Santa Fe is ridiculous. It's like next door. Like we can get a bus, it's there. So that's why it's so predominant here at UF. But there's the engineering club at Santa Fe. There's also the Society of Hispanic Professional Engineers. But it's really hard for students, for professional organizations to care about those topics because they don't understand those topics. So I actually had a conversation last Tuesday with SHEP National, and I was telling, hey, you know, we have a SHEP chapter there that is kind of like abandoned, like what can we do with it? So they're gonna give us access through a proposal. We're gonna get funding, right, to kind of like study like longitudinal data that they have about transfer students and what programs they participate. So we can use that information and bring it to the student chapters and kind of like have a targeted effort to support the student chapters. I remember when I was in Santa Fe, I was like for a year before I left, I think I was the advisor of the group, and we traveled and everything, and it was so impactful for the students. I mean, I remember they were all guys and me. It was so funny, but it was like they competed and they competed, and I think they won or got second place in a particular like round.
Mhm.
And it was so impactful in their life, because this big conference, it doesn't have to be SHEP. You know, if you know, you have other type of conference that you can go to. It could be technical or not. But we need to match them, and the professional society, they need to know. For example, if we can get the professional society to give us foundation money for travel awards, or you know, for programming speakers or whatever, I think that has a lot of impact. But the problem is that this needs money. You need people to give us money, because these are programs. For example, and I cannot put a proposal for NSF if it's not research, right? So, and it's hard because these programs needs to be developed for us to kind of like conduct some research on the impact of them on the persistence of the students. So it's kind of like the egg and the chicken kind of like thing.
Mhm.
But these are really great ideas.
Okay. And so I know it's the case at UF, but are a lot of engineering programs or colleges, I would say, aware of the issue with the transfer students? Are they like, are there more efforts like the ones you're conducting right now in trying to understand what's going on with the transfer students, or try to find solutions to those transition shocks and things like that?
There's people doing an amazing job across the nation. I mean, there's a lot of people in overall STEM, right? Work. I know that their community colleges are really active. Like, I know Miami-Dade, because they have programs in the semiconductor industry. They have submitted proposals as community colleges, right, to get programs in shape, to help the students. And again, and I'm very happy to collaborate with people from the community colleges, but you need the champions, right? And you need to understand that it's hard. And as a professor from a community college, that I was a professor of community college, I do understand how hard it could be, particularly how, you know, politics work in an institution. But we're partnering up. My dream is to have kind of like a center of transfer student studies in STEM. And for that, we need to just do what I'm doing right now with you, have conversations, and, you know, don't think like, what I don't want to do is go to places and say, I'm here to tell you what to do. I actually want to say, like, what do you need and how we can collaborate to really make the student experience successful, whatever that means to them. I mean, I have students that just having, for the first time, they have health insurance. That is a success outcome. Like, it's not a degree yet, but having health insurance, having a stable home, I don't know.
Yeah.
Maybe my heart melts.
Well, we've had conversations on our campus about homeless students. We had a student living in their car for, I think, a whole semester last year. So it's becoming something that very common as a topic of conversation. Yeah.
It
Yeah, and one of-
happened at Seminole Estates as well, that we
Yeah.
were trying to deal with that.
Yeah.
Yeah, and the other thing is the definition also of the students. Like, the success definition is important. It has to come from their voices. The other thing that I think is important conversation to have is, you know, you are in the state of Florida, so we have to be careful on how we address certain issues. So one of the things that I have done is exhaustively like trying to define who I am serving. I'm serving those that are underserved, you know, first generation, low income, international. And so you can have multiple identities of students that we are not looking at them, and underservingness is contextualized. Like whoever is underserved in your state may look different than in ours. And I think that broadens, and even that if I'm studying like first generation student and they tend to be, let's say, Latinos, right? Because we have a high population of Latinos here, so be it. We're just learning about that underserved group and what things we can find out and transferable to other contexts and other institutions, right? So those conversations, I'm also having them because I'm trying to do this workforce development work in the context of our state.
Okay. So now I was trying to come back maybe just to the scale of a physics program or courses, and I wanted to ask you, Kimberly, about that. You mentioned that the impact of the physics classes. So in trying to find out what is it that instructors in two-year colleges are doing well that should be preserved no matter what the pressures are on our teaching environment. So you mentioned something about the experiential aspect of things and the problem solving within the small scale, the small classrooms. Are there anything that you...
The physics courses that I took were taught in a lab classroom. And within that classroom, I believe Physics 1 maybe had 20 students, and I believe that Physics 2 had 8. Something in that range. But because of that freed the professor to give true demonstrations of the physics. What am I trying to say? He was able to give a true demonstration of centrifugal force, or he was able to come out with experimental devices that we could all literally have a moment to hold on to and pass to the next student. And what does it feel like when you have a wheel spinning on a shaft and then you try to change the direction? There's a lot of resistance. Why is that? And unless you can feel it, it's going to be very difficult to understand. If you just try to put that concept into an equation, asking yourself why that's true, or trying to retain that that's true, it is much more difficult. Whereas if you've had that in your hand and you've experienced it, and then you can associate those equations with that physical aspect that you had in your hands, I feel that really aids the retention. So if there's any way that we can ensure that the classrooms, I know it changes the teaching load, but to ensure that the classrooms remain on a smaller scale, and if at all possible, in an environment that is conducive to this type of exploration, I think that at least for me, it had a huge impact. It really made a difference in my understanding of the concepts that were covered.
And did that help you with the engineering courses downstream?
Absolutely. I was speaking with one of my students just the other day, and we were talking about the course load and how she didn't particularly care for physics at the beginning, but now that she's taken her 7th physics class, and I said, wait, your 7th physics class? Are you a physics minor? What do you mean? And she said, no, I took Physics 1, I took Physics 2. She said, but then I came into my engineering program and I took statics, which is just physics. And then I took dynamics, which is just physics. And then I took, and she just started listing all of these courses, vibrations, electrical, basic electrical engineering circuits courses. All of these really have a basis or a foundation of physics at their core. And so if we start off with that strong understanding and then build on it, we're just going to have such a better launching point where we try to add, layers and layers and layers to what exists. But if all my only understanding is an equation that I maybe or maybe not, maybe I did, maybe I didn't quite fully grasp it, then I'm in such a more challenging position as I try to move on and work through the other 5 or 8 or 10 physics courses that we still have left to take.
Well, Cynthia, there's one comment I've been hearing a lot here in Gainesville about how at UF, when the students finish engineering, you can't really tell which one started in the 2-year college and which one really went directly to you. Is that still your observation, or you have data on that?
Yeah, the preliminary data that we collected, yes. So that is called adjustment. So students, there's when you transition into something, there's a phase where you're not one thing or the other, right? So when they go beyond that transfer shock, probably already on the 2nd year, they're already like connected. So that is why I care a lot about that in 1st year, and what are we doing to help them? What culture we're creating for them to feel that they have the mechanisms and they have the support to cope with, which is inevitable. Like, I don't want to say that we want to lessen the transfer shock, because you and me, if we get to a new job, we get transfer shock. If you and me get married, like, that's transfer shock. Like, everything in life has a transfer. What we can teach them is how to cope with them. They have the potential to be successful. They have the potential to be academically successful, personally successful, whatever. But I think we need to provide those support systems. I just want to say about physics, because physics is one of those disciplines that we only think that certain disciplines use it, like electrical engineering and things like that. But physics is fundamental for chemical engineering, for sustainability, for food engineering. I just want to say that contextualizing those things are also important. And again, sometimes the equations are important, but I think the phenomena, understanding the phenomena, the demonstrations that you do at community colleges with 20 students look very different than a demonstration in a room of 600 students. Okay, so that has a lot of value.
So I don't know if you have any data on this, but I'm curious as to whether you have any idea if I'll call it adaptation period, where a person is transferring in, if that is any longer or shorter depending on the number of courses they're taking during the particular semester. Because if it's not, and I suspect it is somewhat independent of the number of courses, maybe having you could call it a bridge program, but a course that they would take during the summer, one course, so that they get acclimated to the college before they start a big full load, might help them be successful.
And that's a beautiful idea. And 1st year students get that class. It's called like university life, something like that. Like something simple that they know where the resources are, et cetera, et cetera. So I'm sorry, my hands is up. But yeah, that's an amazing thing. So we just got access last summer to 20 years of transfer student data. I have a student, all of this takes time. So we already are working with the Institute of Higher Education at the College of Education, and we're going to be desegregating and trying to understand the quantitative side, but we're going to be also coupling that with the qualitative side. And we're going to be following students throughout maybe 2 or 3 years. So again, this is my 3rd year as an assistant professor, and we're like collecting that data. I'm more than happy to show you what we have, but those conclusions are not there yet. But it's like on common sense, right? We know that to help cope, if you have navigational problems, you should have a class like that or some sort of like boot camp. I'm imagining like a boot camp where they can meet professors to do research right away, or companies can come and talk about career, like how to set a resume, how to add value to the job that you have at Lowe's. How do you put those as skills and assets for you to get the next job, which are things that I do with my students, but they're already there for a couple of years. So thank you for that. That's a great idea.
I want to ask a question about something that you said, Cynthia, in your introduction about changing the way that we look at success. And if a student changes majors or something, and that is that really a failure? And Chris mentioned it also, is the idea of we need to broaden the definition of success. And this is something that I taught at Seminole State for many years. And even when I was starting out as a new faculty member, I was thinking something's not right here because, with the performance-based funding and all that, when you're just counting the students, sometimes the best option for a student is to take another path. And if that student figures that out rather than struggling with where the path that they're on, then how can we count those students? Because that's clearly a success in my book, not a failure. So how can we change the way we look at success in such a way that those students aren't counted as automatic failures?
That is the question. That is the question. I think with the value that engineering education, STEM education are putting to workforce development studies and really doing research that is just not about the numbers. Like, again, I'm just in a conference and we just concluded, and this idea of collecting both qualitative data and quantitative data and being able to put voices to whatever the students feel like it's not what we assume are the success outcome is important. The other thing that we were discussing is that, we want to increase the number of groups, right, of participation in science and engineering. So why if I change to chemistry instead of like being in chemical engineering is not a success for society, right? If I train as a chemical engineer, but now I'm doing education, is that really like not a success, right? So, I mean, I think those conversations must happen, but I think we need to learn how to collect data. An important aspect of my work, and Kimberly knows that I share everything. Like one of the things, if I do a protocol, I want to like share the methodology so you can learn how to collect data. So the idea of informing faculty like you, so you can do scholarship of teaching and learning and kind of like collect data and know how to analyze it and get that professional development, I think is really important, because if you do it, we learn. And if I learn, like everybody benefits. And at the end of the day, it's about a kid that can be my son, right? That's what I'm thinking.
Yeah, and it's even more complicated than just a switch of majors and things. And the case that always sticks in my head is a student who was in the engineering program taking my intro physics classes and miserable, just miserable. And, he would do really great and then he'd do really terrible, so it's just this yo-yo. So I finally said, what's going on? We were chatting in the office and he said, I just don't know if this is what I want to do. I really like working with my hands. I'd like to go into carpentry. And this is just not doing it for me. And so I said, well, why are you doing it then? He said, well, my mom wants me to do it.
Yeah.
I'm like, yeah. And then so I'm like, we had a heartfelt conversation. And ultimately, this student left, went to a trade school, and now has his own carpentry or construction company. This is a success. I'm sorry. This is a success. But how do you count that? Because the student left the college. Yet it was clearly a success. But in the, the performance-based funding model, he's a failure because he dropped out before a degree. So it's a very complicated issue.
Yeah, it is. But I think that it's good that we're talking about it.
But do you know if the student actually dropped out? Or if they switched to some other institution and maybe some other program?
Well, they went to a trade school, vocational technical school. But according to the way things are counted in Florida, he's no longer in the university college system. He's somewhere else. And so it was a failure.
Yeah, I'm in a district of 10 colleges, and our district still treats students. Before the pandemic, students really were a Mesa Community College student or this college student. But during the pandemic, students learned to shop. They learned to do the Amazon thing with classes. And I think students are much less tied to an institution now than they were prior to the pandemic, at least at the two-year college level in my area. Maybe it's because we have so many in the area. But we still, if a student takes a course at Mesa, this semester and then doesn't take a course that makes it, but they're still in the district organization, that counts as a not success, which is weird.
So I wanted to come back to something that we actually have been discussing within the physics group here, but you mentioned that also, Cynthia, is that the research aspect of things and having students learn how to do or conduct some kind of research project. So from what you said, it sounds like it would be super beneficial for students before transferring to actually have some kind of experience with that, right? Did I understand that correctly?
Yeah, and there are REUs for transfer students.
Mhm.
So, I mean, but you need to find them and kind of like create a repository and teach them how to put together an application. So there's a little bit of like training that you have to do. I'm more than happy to provide all of the members with kind of like resources to teach the students how to do this. So basically the NSF has a website. I'm going to do it with my son this summer. So we're going to do that. I
Okay.
want him to do it because I told him, if you don't like what you want to do, it's better that you just find out now. Because, you know, if you wait for 2 more years I don't know. I was all, in my experience, I just wanted to have a lot of experience. I did research, I went to co-ops, I did multiple things, and research was my jam. So, you know, I even did philosophy at some point. Yeah, you know,
Oh,
so
I want to talk about that.
yeah, we have to talk about that, but I love philosophy. I have like 15 credits of philosophy. But again, it's important. So there's these resources that we can put together, and they're national resources. I mean, you can partner up, and when I say you, I can help you to make those connections. Like I'm writing proposal centers right now with, you know, engineering research centers, and they are trying to find partnerships. And partnership means like, oh, we are going to have this co-ops or this research opportunities. I'm going to give you the information so you can help, like you can tell the students to apply to it, right? But the thing is that students don't know how to apply, and the professors don't know how the process is if you have never done an REU. But I think creating that type of resources nationally for all of us, for you guys, and I say you, I think it's important physics professors are involved, because you have to take physics to be an engineer.
Right.
Like
Yeah.
there's no way around it.
So
No
we're
matter if
gate-
you do computer,
So we're
you're
the
the
gateway
gatekeepers
then. Yeah. Okay. Well, we've
or
been
the gateway.
Yeah, we've been talking about also research within the context of a physics course itself, and as becoming a component of the courses, in addition to labs and lectures and all that. But yeah, certainly the REU part is significant there as well. Okay, let's see. I'm looking at the time. It's 3:55. The conversation was very interesting. Anybody else wants to make some comment on, because I don't want to keep our guests too long?
Can I just make one more added comment about the REUs, or any research that can be completed at the 2-year level? As Cynthia was mentioning before, oftentimes for the transfer to engineering education, or not engineering education, just engineering. You know, we've talked about what's success, and maybe the student should be in a different field, chemical, instead of chemical engineering or something in that regard. But as a transfer student, that often is not an option. I know Cynthia mentioned it earlier, but if these students had the opportunity to do some research, to participate in one of these REUs, get a taste of what it is to be a mechanical engineer, or a chemical engineer, or whatever the field is they think that they want to go into, they have that opportunity prior to transferring into the university system, they may save themselves a situation in which they don't have a choice to transfer. They either have to change programs. They either have to complete the program that they are pigeonholed into because that's what they transferred into, or drop out, you know. So definitely that early research, I think, could be incredibly impactful.
And that means that we need to talk with the academic advisors, because you not need to plan then for the student not to take classes in that summer, because it's a 10-week commitment that they get paid, they get travel, they get housing. It's amazing. Not necessarily is in engineering. I'm saying like there's REUs for everything in STEM. So it's a great opportunity for you to taste water, but also to taste something that you never thought that you could do. Like you could be on a lab working in chemistry, but the applications are in drug delivery, or they are in medicine or whatever, right? So imaging or physics, like more imaging. So again, I think I would love to maybe create resources, or I know you have a website. I know that you have all of this concentration of, you know, amazing professors. So I think maybe we can put together a draft of resources on this topic, and then it could be in like an open access, like Google form or Google thing, and everybody can comment and say, I don't understand how to do this. I did this and didn't work, until maybe in a year we have something that works, and you can go and talk with academic advisors and, you know, I don't know, contextualize it to your reality.
Well, sounds great. Yeah, it's a great idea.
And the reason why I say that I'm gonna do it is because I'm gonna do it with my son. So it's gonna be there anyway. So I better share it with all of you.
All right, it's a good timing then. Okay. Well, I just want to quickly add one last question. So in physics, physics education has at some point become its own discipline, and there's research being done in that area, and people get degrees specifically in physics education research. I'm wondering, is engineering going to go in that direction as well? Is there a discipline that will become engineering
It
education?
is. So
Yeah?
we are the 11th department in the nation.
I see. Okay.
Yeah. So
So
it
we-
is, but we do a lot of STEM education, like this idea of like both. So a lot of the articles, so you can focus on maybe engineering, but you can also do STEM, and we cross over, recognizing that it's so connected, particularly in the early years. So if you do first year, second year engineering, that is not engineering, that's STEM, because
Mhm.
they're taking chemistry, physics, you know, math, etc.
Okay. Okay, well, it was a great pleasure to have you here, and I think we've learned quite a bit in terms of the engineering TYC connection there. And I
Thank
think
you
it
so
gave us-
much.
Yeah,
Yeah.
give us